All right, everybody. In this video, we are working to find the probability. And in this case, we're going to be using a table. We did something very similar in class. There's a little bit of a variation from the activity that we did in class, but I'm going to show you how you would use a table and how you would use multiplication to actually accomplish the exact same thing. Okay, so in this particular example, we are comparing the probability of one simple event to the probability of another simple event. Now, if you recall that a compound event is going to consist of two or more simple events. A simple event is one in which there is only one answer. So again, rolling a dice, you get one answer. 1, 2, 3, 4, 5, or 6 typically on a regular dice. Or if you're going to flip a coin, there's only two options. There's either heads or tails, a simple event. Now, to find the probability of a compound event, you can write a ratio of the number of ways that the compound event can happen to the total number of equally likely possible outcomes. In this case, we're going to use a table. Now, Jacob rolls two fair number cubes. Find the probability that the sum of the number that he rolls is going to be 8. So we're going to use the structure of the table that you see there. All that we're going to do in each cell. So, for instance, in the cell that I'm hovering over right now, if he rolls a 1 and he rolls a 1, what's going to be my sum? Of course, it's going to be 2. Probability that the sum would be, if he rolls that green dice and the blue dice, the sum, of course, is going to be 3. So what I'm going to do is I'm going to go ahead and go over to my drawing. I'm not going to belabor this and make you add everything up or watch me add. I'm going to show you the table that's already completed. And so the next screen that you see will be my completed table. As promised, you see the table. Okay, so again, if you notice here, if I had and I believe that this was and I'll switch back over. I believe that the top was the green. Okay, we have the green. And then on this side, we would have the blue. Okay, so going down blue and going across green, of course. Now, if I were to roll those two cubes, I had a 1 on the blue and I had a 5 on the green, I'm going to add that up. Of course, it's going to be 6. So it was asking for what is the sample space in this particular case. The sample space, remember, is going to be all of my possible outcomes. And all of my possible outcomes will be 1, 2, 3, 4, 5, 6. Okay? Times the 6 on this side. So 6 times 6, as we know, is going to be what? 36. Now, all of the possible ways that I can get to 8 are by rolling 2 here, 6 there, 3 there, 5 here. So I'm going to circle all of my 8s. Okay? So how many possible favorable outcomes could I get to 8? How many are there? Just count them up. 1, 2, 3, 4, 5. We have 5. Okay? Now, I'm going to look at the probability for the sum of 8. Now, if we remember correctly, our favorable outcomes over our total outcomes, also known as our sample space, will be what? Possible outcome, or favorable outcomes, again, is 5. Over the total number of outcomes, it's going to be that. It is just that simple. Okay? This is two different simple events. Two different simple events. Now, in this particular case, I am comparing using a table, okay? Because I could literally roll them, and show you, but I can use a table to show me the exact thing. So what if I wanted to figure out something else, okay? And I'm going to use a mathematical or computational way to figure out the exact same thing. The next thing that you see will be those examples. All right, so let's think about this. And looking back at our table, what if I wanted to figure out what was the probability of rolling a sum of 4, and at the exact same time, I wanted to get the probability of rolling a sum of 7, okay? I just wanted to figure out what was the probability of that possibly occurring, okay? So if I were to take the number cubes, first of all, roll them, get a sum of 4, and then roll them and get a sum of 7, on the second time, is there actually a probability of that occurring? If it is possible, of course it could happen, okay? There's never going to be a time when, in this particular case, where there is a 0 probability. So let's just figure out how large or how small that probability is. So what is the probability of rolling a sum of 4? I could identify that by circling all of my 4s. Okay. What is the probability of rolling the sum of 7? Okay, the sum of 7. Let's look at that. And what I'm doing is I'm just circling all of my instances. Okay, so if we remember, our possible outcomes or sample space total outcomes is always going to be out of 36. All right, and then if I roll a 4, that is going to be what? 4 out of 36. Rolling a sum of 7 is going to be what? 6 out of 36. I could simplify both of these, 1 to 1 over 9, and the other to 1 over 6. So once I do that, I can now compare that 1/9 multiplied by the 1/6, and that's how I do it. I'm going to multiply both of these probabilities by each other in order to get what the probability would be of both of those things occurring at the same time. I'm going to get approximately 1 over 54. Now, how do I make that look like? And again, go back and watch my other videos about showing what the complement would be. In that video, it's going to show you, I also think, the qualitative description of probability. Okay, so if I wanted to figure this out, all I have to do is divide 1 divided by 54. What I'm going to do is I'm going to get approximately the decimal 0.018. The decimal does go on, but I'm going to cut it off at 3 digits beyond the decimal. So approximately 0.018. That's going to be approximately 1.8%. Okay. Now, if we think about this in terms of a probability, okay, that is about 98.2 as a complement that's not going to happen, or about 1.8% that it will. If we think back to our qualitative version of probability, that's going to be somewhere between impossible and unlikely, closer to impossible. So in this particular case, that is going to be highly, highly unlikely that that would occur. And that's how you calculate that with mathematics. So we have a table version and we have mathematically. Okay, you would pick the option that works best for you. All right. At this point in time, please back up this video if there's something that is unclear, or come to class with a question in hand. Also, you may come to tutorials twice a week to ask me that very same questions. I welcome those. And as always, I will see you tomorrow.